The invention of the battery. Introduction. Look around you. Your phone, your laptop, that remote control, even your car. What do they all have in common? They're powered by a seemingly simple, yet profoundly complex device, the battery. It's the silent workhorse behind our portable, digital lives, but its origins are far from silent. Welcome to History and Inventions, where we explore the innovations that shaped our world. Today, we're sparking up the fascinating story of the invention of the battery. How a curious frog's leg and a stack of metal discs unleashed the hidden power that fuels our modern existence. Chapter 1. The Spark of Life, Galvani, Frogs, and Animal Electricity, late 18th century. Our journey begins not in a factory, but in a laboratory in Bologna, Italy, with a physician and anatomist named Luigi Galvani. In the late 1780s, Galvani was studying animal anatomy. Legend has it that in 1791, during experiments with dissected frog legs, his assistant accidentally touched a brass hook holding a frog's leg to an iron railing, causing the leg to twitch. Galvani, fascinated, dedicated himself to studying this phenomenon, concluding that the muscle contractions were due to a unique animal electricity residing within the frog itself. He published his findings, igniting a fierce scientific debate. Chapter 2. The Voltaic Pile, Unlocking Metallic Electricity, 1800. Enter Alessandro Volta, a brilliant Italian physicist and contemporary of Galvani. Volta respectfully disagreed with Galvani's animal electricity theory. He suspected the electricity wasn't from the animal, but from the contact between the two different metals and the moist conductor, the frog's tissue. Volta began his own experiments, stacking alternating discs of two different metals, zinc and copper, separated by cardboard soaked in brine, salt water. When he connected wires to the top and bottom of this stack, it produced a continuous electric current. In 1800, Volta announced his invention, the Voltaic Pile. This was the world's first true electric battery, a device that could produce a stable, continuous flow of electricity through a chemical reaction. It was a monumental breakthrough, providing scientists with a reliable source of electric current for the very first time, opening the doors to a new era of electrical discovery. Chapter 3. Early Innovations. From Labs to Practicality, 19th Century. The Voltaic Pile was revolutionary, but it was also impractical for everyday use. It dried out quickly and wasn't very durable. The 19th century saw rapid development as scientists and inventors sought more efficient and robust battery designs. The Daniell Cell, 1836, developed by British chemist John Frederick Daniell. This copper-zinc battery provided a more stable and longer-lasting current, becoming a standard power source for telegraph networks. The Leclanché Cell, 1866, French inventor Georges Leclanché created a wet cell using a carbon rod, a zinc electrode, and an ammonium chloride solution. This battery was more reliable and could be made in a dry form, making it suitable for early telephones and doorbells. This was the precursor to the modern dry cell. The lead-acid battery, 1859, invented by French physicist Gaston Planté. This was the first rechargeable battery. It used lead plates immersed in sulfuric acid. Though heavy and bulky, its ability to be recharged repeatedly made it invaluable for early electric vehicles and power storage. These innovations transformed the battery from a laboratory curiosity into a practical power source, ready to be integrated into emerging technologies. Chapter 4. Powering Portability, the Dry Cell and Beyond, late 19th, mid-20th century. The invention of the dry cell battery by German inventor Carl Gastner in 1886 was another game-changer. It was a variation of the Leclanché cell, using a paste electrolyte instead of liquid, making it spill-proof, truly portable, and much safer. The dry cell led to a boom in portable devices, flashlights, portable radios, and later, early cameras and toys. By the early 20th century, companies like Eveready and Duracell were mass-producing these ubiquitous power packs. The mid-20th century saw the development of alkaline batteries by Louis Urey in 1959 at Eveready, offering longer life and higher power density than the original zinc-carbon dry cells. These advancements laid the groundwork for the explosion of consumer electronics. Chapter 5. The Lithium Revolution and the Future, late 20th century, present. While lead-acid and alkaline batteries dominated for decades, the need for lighter, more powerful, and rapidly rechargeable batteries for computers, phones, and electric vehicles sparked the next revolution. The lithium-ion battery, first commercialized by Sony in 1991, became the dominant choice for portable electronics. Its high energy density, lighter weight, and excellent rechargeability made it indispensable for the digital age, powering everything from laptops to smartphones. Today, battery technology continues to evolve at a blistering pace. From solid-state batteries promising greater safety and energy density to grid-scale energy storage for renewable power, batteries are at the forefront of our energy future. Conclusion. From Galvani's twitching frog leg to Volta's ingenious pile, and through centuries of relentless innovation, the battery has quietly transformed our world. It's the unsung hero that untethered us from power outlets, enabled portability, and fueled the digital revolution. The battery didn't just store electricity, it stored the potential for an entirely new way of life, empowering us to take power into our own hands. What's the most surprising way the battery has impacted your daily life? Share your thoughts in the comments below. If this powerful journey through invention history electrified you, be sure to like this video, subscribe to History and Inventions at History Inventions, and hit that notification bell so you don't miss our next fascinating story.